Have you ever wondered how apps like Facebook or Instagram fetch data from their servers? Watch this video till the end and you will learn how to craft REST APIs like a pro. REST API utilizes an HTTP request response model, where a client sends requests to a server and server responds with requested data. REST API allow different software applications to communicate over the internet using standard HTTP methods and structured data formats, typically JSON and XML. But before we delve into advanced topics, let's start from the basics. Why REST API use HTTP? Because it's powerful. It provides several capabilities that make communication between client and server agile. URI structure provides organization in data. HTTP methods allow differentiation between different actions such as reading, creating, updating, and deleting. Response status codes convey the results of request processing. Headers provide additional information. SSL is a secure way to transfer data over internet. Now that we understand the basics, it is time to create a basic REST API. This hands-on experience will help you gain a deeper understanding of how REST API are constructed. Imagine that you are the founder of popular foodie app called Foodie Hub. Foodie Hub helps users discover and explore the best restaurants and dishes in their area. Users can read reviews, view menus, and even place orders for takeout or delivery. You've received feedback from your users that they want real-time updates on restaurant wait times. They want to know how busy a restaurant is before they decide to dine in. Intrigued by this challenge, you decide to implement REST API within Foodie Hub. This API will allow your app to communicate with restaurant servers to retrieve real-time wait time data. Users will be able to see wait times and make informed decisions about where to eat. When a user opens the app and selects restaurant, the app sends a GET request to the API. The API in turn communicates with the restaurant server using HTTP GET. It retrieves live wait time data and sends it back to the Foodie Hub app, which displays to the user. As the founder of Foodie Hub, you've successfully implemented real-time wait time information using your REST API. Now, you want to take your app to the next level by allowing users to interact more with restaurant listings. This includes adding new restaurants, updating restaurant information, and removing outdated listings. Users can now submit information about new restaurants they discover. You create REST API endpoint, API v1 restaurants, which accepts POST requests. When a user submits a new restaurant, the app sends a POST request to the API with the restaurant's details. The API validates the data and adds the new restaurant to the app's database. Users can help restaurant information up to date by suggesting edits. You create a REST API endpoint, API v1 restaurant ID, which accepts PUT requests. When a user suggests an update, the app sends a PUT request to the API with updated restaurant information and the restaurant's unique identifier, restaurant ID. The API validates the request and updates the restaurant's details in the database. In cases where a restaurant has closed or is no longer relevant, users can request its removal. You create a REST API endpoint, API v1 restaurant ID, which accepts delete requests. When a user requests deletion, the app sends delete request to the API with the restaurant's unique identifier. The API verifies the request and removes the restaurant from the database. And of course, you want to send a list of restaurants. The REST API endpoint is API v1 restaurants, which accepts GET requests. All these operations, known as CRUD, create, read, update, and delete. At this point, you already know how REST APIs work. I'm going to show you some more interesting examples, so stick around. With the Foodie Hub app, allowing users to create, update, and delete restaurant listing, you realize the importance of controlling access to these actions. To ensure that only authorized users can perform these operations, you decide to implement user authentication and authorization. Users must create accounts and log in to access advanced features like adding, updating, and deleting restaurant listings. You create REST API endpoints for user registration and user login. Upon successful login, the API generates a unique authentication token, GWT, JSON Web Token, for the user. This token is returned to the app, and the app includes it in the headers of subsequent API requests. For each advanced API action, the API performs authorization checks. You must implement different permission levels to control who can perform which actions. Assign user-specific roles and permissions based on their level of trust and responsibility. As Foodie Hub continues to grow, the number of restaurant listings in the app has increased significantly. Users are finding it difficult to navigate the listings. To address this, you decide to implement filtering, sorting, and pagination options to improve usability. Users can now filter restaurant listing based on specific criteria, such as cuisine type or location. You update API endpoint that accepts filters parameters, such as cuisine and location. Also, users can sort restaurant listing based on preference, such as rating, price range, or alphabetical order. To prevent overwhelming users with a long list of restaurants, you implement pagination. The API returns a limited number of rows per page, and user can navigate through pages using pagination parameters, like page and per page. In this video description below, you'll find a link to download our Ultimate API Guidebook. This comprehensive resource is packed with in-depth insights, practical tips, and real-world examples that will take your API expertise to the next level. Thank you for watching, and remember to like, subscribe, and share this video.